So we'll pick up with example 9 and do a few word problems here. It says, how long to the nearest tenth of a year will it take $1,000 to grow to $3,600 at 8% annual interest compounded quarterly? So the first thing we have to remind ourselves is which formula we're using. If it says compounded quarterly, we want to use this formula. Okay? So, it says how long to the nearest tenth of a year. That means we're looking for time. $1,000 is the starting amount, so that's going to be our P, principal. It says to grow to $3,600, so that's going to be our ending amount. That's going to be our A. 8% annual interest is going to be our R, but we want to change that, so we'll do 8 divided by 100, and we get 0.08. And compounded quarterly, quarterly means like 4 times, because 4 quarters in $1. That's our N, 4 times a year. Okay, so we'll put those numbers into our formula. We have 3,600 equals 1,000, parenthesis 1 plus 0.08 over 4 to the 4 times t power. So we need to clean some things up here. First of all, this number that's in front of the thing that has the exponent, this whole thing is the part with the exponent, we're going to get rid of. It's really 1,000 times, so we'll divide both sides by 1,000. And 3,600 divided by 1,000 is 3.6. Now at the same time, let's do what's in here in our calculators. So 1 plus 0.08 divided by 4 is 1.02. And 4 times t is just 4t. So remember, to solve anything that has an exponent, we have to use logs. So we're going to put a log in front of the 3.6 and a log in front of the 1.02 to the 4t power. And remember that allows us now to take this 4t, that's the exponent, and put it out in front. We can't do that until we have a log written there. So now let me clean up some space so that I can rewrite this and we can keep working. Okay, so this 4t, remember, is coming out in front. And that gives us still log of 3.6 on the left. And we'll have 4t log of 1.02 on the right. Now on the right, we only want that t. We don't want the 4, so let's divide by it. And we don't want this log, so let's divide by it. If we do that on the right, we also have to do it on the left. So over here, it's going to cancel out the 4, and it's going to cancel out that log. And that leaves me with just t. And on the left-hand side, now we want to do this in our calculator, but we have to be really careful because the denominator has more than one piece to it. We need to put parentheses around the entire denominator. So in our calculator, we'll type log 3.6, close the parenthesis, divided by, and then we'll put a parenthesis for the denominator, 4, and you can put times or not, it doesn't matter, log 1.02, close the parenthesis for the log, that's this purple parenthesis right here, and then the second parenthesis for the denominator. So you have 2 parentheses in a row, equals, and that gives us 16.171. The 1 after the 7 tells us, oh no, we're rounding it to the nearest tenth. It says nearest tenth here. So the 1, 7, the 7 tells us to make that 1 before it a 2. So it's 16.2 years. So let's do another one. So here we have $8,000 is invested at 8% annual interest rate. How long will it take to double if the interest is compounded continuously? So this continuously tells us that we're using the formula A equals PE to the R times T power. So 8,000 is invested, so that's our beginning amount, that's our principal. 8% is our interest rate, but we don't want to leave it like that. We want to divide it by 100 to get 0.08. And then it says to double. So if we take 8,000, we want to end up with this. So this is our A. So we're taking 8,000 and doubling means times 2. So A is going to be 16,000. And we're trying to find time. It says how long. So 16,000 equals 8,000 e to the 0.08 times t. Now again, remember that this is really 8,000 times e. We have to get the e by itself. So we're going to divide both sides by 8,000. And that leaves me with e to the 0.08 t power. On the left-hand side, we get 2. So remember that if we've got e, we're going to use ln on both sides. So we'll have ln of 2 equals ln of e to the 0.08 t. Remember, ln cancels out e, so now we just have, just do it over here, ln of 2 equals 0.08 t. So we'll just divide both sides by 0.08. I should keep that 2 in parentheses for our calculator. So that's going to give us, we'll just type that into our calculator, ln of 2, close your parenthesis, divided by 0.08. And it doesn't tell us, but we'll say to the nearest tenth again. So that's 8.66. That 6 tells us to round the first 6 to a 7. So we'd have 8.7 equals t. And that would be 8.7. Time is always in years in these problems. So now we're going to practice just things that we've already talked about. We're not going to, this doesn't have anything new in it, but we just want to kind of review problems mixed up. It'd be really good if you could turn off the video and practice, see if you can do this problem, these problems before we do it together, just as a way of looking back and seeing how well you understand things. So this is a log problem. We've got logs in 2 different spots, which means we have to smash them together. The plus tells us we're going to smash them together as multiplication. So we have x times 2x plus 1 equals 1. Remember that we have logs, we want to use exponents, so we're going to rewrite it in exponential form. This is a base of 10. So we have 10 to the first power equals x times 2x plus 1. And that gets rid of our logs, that's why we use exponents. So 10 to the 1 is just 10. Over here we have to distribute 2x squared plus x. And subtract 10 from both sides, because anytime I have an x squared, I want it to equal 0. So I have 2x squared plus x minus 10. I can factor that. We'll have a 2x at the beginning of one parenthesis and x at the other. 10 I want to do is 5 times 2 I'm going to put the 5 here and the 2 here, because then when I multiply, 2 times 2 is 4x, and a 5x here. I want the 5x to be positive and the 2x, the 2 times the 2x, the 4x to be negative. So when I check that, I get 5x minus 4x gives me the x in the center. So I'm going to set each one of those equal to 0. Here I'd subtract 5 from both sides. And I get x is equal to negative 5 over 2. Now when I go to check this one right here, this negative 5 over 2 is going to make it negative. It's going to cause a problem. So I'm going to have to cross that one out. So I'll do the other one. I have x minus 2 equals 0. And that gives me a 2. So I have to check it back over here. When I put it in place of x, I get 2, which is positive, so that's okay. 2x plus 1, I put it in place of there, I get 2 times 2 plus 1, and that's positive, so that's okay. So this is my answer. This has an e in it, so that means I need to use ln. So I'm going to put ln in front on the left side and ln in front on the right side. The ln and the e cancel out, which just leaves me with 4x. ln is 75. And I can divide both sides by 4. And the exact answer, or the solution set, would be ln of 75 over 4. I can put that in my calculator. Just make sure you close your parentheses after 75. And that gives me 1.08 if I round it. So again, this is my exact answer, and this is rounded. So here again, I have 2 logs, so I have to smash them together. It's subtraction, which means that when I smash them together, it becomes division. So I have x minus 2 on the top and x minus 3 on the bottom equals 2. Again, remember, when you smash them together, you just have one log. So now I'm going to rewrite it in exponent form. So I get 4 to the second equals this. Four to the second is 16. And I'm going to write these pieces with parentheses around it because I need to keep them grouped together. I'm going to multiply both sides by this denominator so that it can cancel it out over here. Over here I need to distribute, so I'd have 16x. 16 times 3 is 48. And that equals x minus 2. So I'd subtract x from both sides, so I get 15x. And let me just at the same time go ahead and add 48 to both sides. Gives me 46 over here. So I have 15x equals 46. Now I divide both sides by 15. So that gives me 46 over 15. And I don't think that reduces, so we'll just leave it as 46 over 18. This is an exact answer. And we need to check it. Remember, we need to say, okay, if I have x minus 2, and I put 46 over 15 minus 2 into my calculator, 46 divided by 15 minus 2, I get a positive answer, so that's okay. And let's see what happens if I do minus 3. So that's, I'm checking the x minus 3 piece. So I have 46 over 15 minus 3. And I still barely, but I still get a positive answer. So this is an okay. Okay, here I have an exponent, but I have something in front of the item with the exponent. So I have to divide both sides by that 8 first. And that gives me 4 to the x minus 5 equals 60 over 8. I could go ahead and divide them both by 4 to make the numbers a little bit smaller. Let's just leave it. It doesn't really matter. Okay, now when I have exponents, I want to think that I need to use logs. So I'm going to put the log in front of the left-hand side. And I'm going to put a log in front of the right-hand side. Now that allows me to take this exponent and put it out in front. So now I have x minus 5 times log of 4 equals log of 60 over 8. I want to get rid of that log of 4, so I will divide both sides by log of 4. And that leaves me with x minus 5 equals log of 60 over 8 over log of 4. And then I would need to add 5 to both sides. So my exact answer would be log of 60 over 8 divided by log of 4, and that plus 5 is just big off to the side. Again, that's exact. To type it in my calculator, I do it just like I see it. Log of 60 divided by 8, close my parenthesis, divided by log of 4, close my parenthesis, plus 5 equals, and I get 6.45. We'll do a few more. So this is logs again. We want to smash things together so that we have just one log on the left-hand side. So if I smash the left-hand side together, it's subtraction. I have to do division. And this is one of those nice ones where we have a log on both sides, which means we can just cancel them out. So I get x over x minus 3 equals 3. I'll put that denominator in parentheses and multiply both sides by it. That's nice because it cancels it out over here. So I get x equals, and here I need to distribute it, 3x minus 9. I'll subtract 3x from both sides. So I get negative 2x equals negative 9. Divide both sides by negative 2. And the negative cancel out, leaves me with just 9 over 2. So I need to check that. It's positive, so the x part is okay. But this x minus 3 part, let's try it. 9 over 2 minus 3 is 1.5, so that's positive as well. So this is an okay answer. Okay, this is an exponent problem, which means we have to get the piece that has the exponent by itself first. So first thing we'll do is subtract 5 from both sides. Oh, that's 36. Then we'll divide both sides by 3. And now that we have the e by itself, we want to use ln on both sides in front of it. So ln and e cancel out, leaving us with x equals. ln of 12 is our exact answer. We can type that into our calculator, and we get 2.48 as a rounded answer. This is a log problem, and that log is already by itself, which means we're ready to write it in exponent form. So we'll do 4 to the third power equals 3x plus 5. So 4 times 4 is 16. 16 times 4 is 64. So we have 64 equals 3x plus 5. We'll subtract 5 from both sides. That gives us 59 is equal to 3x. Divide both sides by 3. It doesn't come out evenly, so usually with fractions we'll just leave it as 59 over 3. That's an exact answer. We do want to check and make sure that it doesn't cause a problem in our log. So this is the inside part of our log. So we'd have 3 times 59 over 3 plus 5. You can do that in your calculator, but that's a positive number, which means this is an okay answer. And our last one is an e, and the e is not by itself, so we need to divide both sides by 1,000. And that gives us e to the 0.08t equals 5. And then once e is by itself, we put ln in front on both sides. And usually when I stick in a log, I put that number or whatever that is in parentheses after it. Remember, ln and e cancels out, so we have 0.8t equals ln of 5. And now we can divide by 0.08. So t is equal to ln of 5 over 0.08. And this is exact. In your calculator, you could do ln of 5, close your parenthesis, divided by 0.08. And we can find that t is equal to 20.12, depending on how it asks you to round. This is rounded. So you just have to really pay attention to what kind of problem it has. If it has an exponent, you want to get the thing with the exponent by itself first, and then use logs. If you have logs, you want to smash logs together if you need to, and then rewrite it in exponential form to get rid of the logs. And then at the end of log problems, you have to check and make sure you don't get numbers that give you negatives inside the logs.